Hello everyone, I'm Zhang Fan, and I am an engineer at Huawei. Today, I'm going to introduce the MDC-based Multisite Private Cloud Interworking Orchestration Solution in Huawei's CloudFabric Data Center Network Solution. The scale of a single data center, or DC, is limited and can be expanded only to a certain extent. As a result, resources of a single DC cannot meet the increasing service requirements. Therefore, multiple DCs are needed to deploy services. In addition, as data security, service reliability, and service continuity are becoming more and more important, backup and disaster recovery (DR) have become common requirements, which also requires multiple DCs to be built. A typical solution for building multiple DCs is the Georedundancy Solution. In this solution, active DCs are deployed in the same city, and a DRDC is deployed remotely to synchronize data with the active DCs. If a fault occurs in the active DCs due to factors such as natural disasters, the remote DRDC can quickly recover data in applications to ensure service continue to run as normal and reduce any losses. Because the active DCs and DRDC are located in different regions and far away from each other, they cannot be managed from one controller. To solve this problem, Huawei's CloudFabric Data Center Network Solution provides the Multisite Solution, which can be used for the interconnection of multiple remote DCs. Traditionally, to orchestrate cross-DC network services, network engineers need to deploy complex interworking protocols between DCs and coordinate interworking parameters. This poses high requirements on network engineers, takes a long construction period, and is prone to errors. In the Multisite Solution, network engineers need to configure services separately on multiple iMaster NC fabric controllers and manually ensure that interworking parameters are consistent. To address the preceding challenges, Huawei's CloudFabric Data Center Network Solution provides the MDC-based Multisite Private Cloud Interworking Orchestration Solution. MDC stands for Multi-Datacenter Controller. It invokes APIs of the domain controller in each DC to centrally orchestrate, provision, and present cross-DC network services. To better understand this solution, I'm going to introduce some concepts. In this solution, fabric gateways in the DCs that need to interwork with each other are logically grouped into a resource pool, which is called a transit fabric. In this way, a virtual resource pool for multiple DCs is formed. The MDC delivers the cross-DC interworking configuration to fabric gateways in the transit fabric. A transit VPC dedicated for DC interworking can be created on demand after being associated with the transit fabric. To implement interworking between tenant VPCs across DCs, you can connect these tenant VPCs to a transit VPC and set the interworking parameters and policies. Now let's take an example to further describe the principles of and operations on the MDC. In this example, multiple service fabrics need to interwork with each other through a centralized VAS fabric. In centralized VAS mode, VAS devices are deployed in an independent fabric. In distributed VAS mode, VAS devices are deployed in each service fabric, and the VAS resource usage may differ greatly across different fabrics. When the centralized VAS mode is used, the traffic that needs to pass through firewalls is diverted to the firewalls in the centralized VAS fabric for security control, improving the VAS resource usage across the entire network. When network orchestration is complete on the MDC, it sends instructions to the domain controller in each fabric. The domain controllers instantiates transit VRFs on fabric gateways in the three fabrics and automatically configure routes between them and routes destined for firewalls to implement cross-fabric service access. Next, I'd like to briefly talk about how to perform configurations on the MDC. Before performing configurations, ensure you have done the following: adding domain controllers to the MDC for management, creating a transit fabric, setting global parameters, creating a VAS resource pool, and orchestrating tenant VPCs that need to interwork with each other between two DCs. The orchestration model for the example is as follows, which contains three phases. First, log into the MDC, create a transit VPC, and select the created transit fabric. enter the orchestration mode of the transit VPC, create a transit router, and select the VAS resource pool through which traffic will pass. Then create a tenant router, which is automatically associated with a transit router. Associate the tenant router with a logical router created on the main controller. That is the tenant network to be interconnected. Finally, deliver the transit VPC configuration. Similarly, create another transit VPC, a transit router, and a tenant router in the transit VPC in this order. Create an external transit router in the local transit VPC and specify the peer transit router, that is, transit router 50 created in Phase 1. Then specify the centralized VAS resource pool. If two VAS resource pools are selected, you need to specify the active and standby relationship between them. Finally, specify the local and destination subnets that need to communicate with each other. After these operations are complete, the MDC instructs the main controllers to provision services. Wait for a moment until the service provisioning is complete. On the MDC, you also can centrally manage service resources of multiple DCs. For example, you can check the management status and resource usage of all the main controllers. Check the fabric gateways in the transit fabric and the status of the VXLAN tunnels established between them. After the interworking service is orchestrated and delivered, you can view the visibility results of logical and physical networks. In addition, you can verify data consistency between the MDC and the main controllers to detect and eliminate any inconsistencies with one click. In this video, I introduced the MDC-based Multisite Private Cloud Interworking Orchestration Solution in the CloudFabric Solution and described the interworking principle and operation process using the centralized VAS-based interworking scenario as an example. The MDC provides users with unified network orchestration and O&M for cross-DC interworking services. That's all for this episode of Test It, Believe It. Thank you for watching.